The universe is beyond immense, and yet it might be nothing more than a tiny dot beside the rest of reality. I'm not sure how long it was after the first telescope was invented that we began really realizing that the stars numbered not in the thousands, but in almost uncountable quantities. Billions and billions. I can't imagine it took long before they at least wondered, though. Certainly by Isaac Newton's time, they were already thinking it must stretch out infinitely far in every direction, including time, for everything not to collapse in on itself from gravity. This does not appear to be the tale of our own universe, which is stupefyingly ancient and large, but not infinite in either regard. It seems to have begun about 14 billion years ago, and the part we can see stretched out 47 billion light years in every direction. We don't think it stops there, since we can see that far in every direction out from Earth, and we assume Earth is not the center of the universe. But we don't know how much further it goes, and have no way we can think of to look beyond that horizon that wouldn't seem to violate some laws of physics. Indeed, it might not go any further at all. Earth might really be the center of everything. That is what the current evidence actually shows. But we tend to assume not, and often did even for modern astronomy or Copernicus. The Greeks were actively debating the enormity of the universe, at least as early as the 6th century BC, and were not alone in that. Not much was written down then or before, so we probably couldn't say how many civilizations thought the universe was just that immense, but we have other accounts. Perhaps the best known, if rarely discussed in this context, would be the Bible. In Genesis, God promises Abraham and Isaac that their descendants will be as numerous as the stars themselves. You can only see a few thousand stars in the night sky. Scholars and theologians certainly debate the who and when of that book's authorship, but under any of the accepted dates, from Moses writing them till 400 BC, the idea that the descendants of Abraham only numbered a few thousand would be considered laughably small rather than a promise of untold greatness, and thus they were probably assuming a lot more stars than they could see. If we assume divine origin, then God presumably knows all the 200 billion trillion stars we currently estimate in the observable universe, and could number any additional ones too. Nor is that the only religion dating to that era that thought reality was quite huge if not infinite. We have from the Jataka tales, circa 3 to 400 BC, nowhere between the lowest of hells below and the highest heaven above, nowhere in all the infinite worlds that stretch right and left is there the equal, much less the superior, of a Buddha. And as we move into the last couple thousand years, it seems to just be taken for granted that there are more things in heaven and earth than are dreamt of in your philosophy, if you're just looking out at the world around you and those visible stars. I thought we should start by acknowledging, as we get ready to explore the multiverse and wider cosmos, that the idea that the cosmos is massive, if not infinite, is not some new concept from science. And indeed, all science actually tells us is that there appears to be an expanding bubble of spacetime that at its apparent rate of expansion would have been a tiny dot 14 billion years ago. There is no evidence from science for any type of multiverse, and our reasoning for it isn't, honestly, any better than our ancient ancestors had. Arguably worse, since they might have been getting it directly from the mouth of a higher power. If not, they presumably had just thought, this place is huge, and I've never seen an end to it. And what would be beyond the end anyway? Just more stuff, right? I think most of us have pondered along those same lines of reasoning, even without scientific understanding or explanation. Wondering what is beyond the horizon is nothing new to us, and nor is wondering if there's ever an end to those new horizons, and what might be beyond such an end, if it all just curves back in on itself or extends forever outward. And if that ever more distant land is just more of the same or grows ever stranger too. If you journey far enough, does reality fray and turn surreal or chaotic? I don't doubt that long before science came around, we contemplated going and exploring those strange new worlds, and indeed our shared mythologies offer lots of tales about that too, fey realms and underworlds at least. But as we consider exploring them today, we need to review the various types of multiverses science suggests to us, even if it offers no proof or evidence for them. And for although I do tend to poke at multiverse theories as being a bit non-scientific in the classic context of not being falsifiable at this time, science really does offer us reasons, and different ones pointing in different directions to different types of them. I will mention some of the evidence that points to some models as we go, but today I'm more interested in explaining their basic shapes, so to speak, which can even include weird geometries like circles that don't have 360 degrees inside them, but some other angle, and what we might explore them for and why we might colonize them. We did cover the science angles more about 360 episodes back in our look at parallel universes and alternate realities, so it's probably time for a second look, and we've contemplated the topic from a Fermi paradox perspective too, but there's more types to cover than we got to in those episodes, and more importantly, we never really talked about how that journey might impact us, or what a civilization spreading over them might look like. Of course, there's no guarantee any of these places exist. Indeed, some might be mutually contradictory to each other if they did exist, one or the other, not both, and even less reason to think we could ever explore them if they did. But if we can explore them, we can probably settle them too. Let me explain that. In physics, to look at something, we must receive some sort of particle or force from it, or bounce something off it. You can affect it in some way or are affected by it, and thus we have the principle that no observer or experimenter can make an observation without altering the system they observe or being altered by it. Such being the case, if we can in any way detect some other place outside our observable universe, rather than simply deduce it from the existence of Hubble expansion or quantum mechanics, or the existence of time or the weakness of gravity, then you must be able to send or receive data and push or pull on something there. If you can do that, then with skill you can push or pull matter there into some pattern, and that pattern could be a person, for conceptual purposes. In practice, you would expect it to be the tiniest possible self-replicator or assembler, which could then be used to build more stuff to serve as a beachhead for explorers or settlers. Depending on the type of universe we're imagining stepping into, this might be requiring machinery or biology which could not possibly function in our own reality, as it might have atoms built out of entirely different subatomic particles, for instance. There are a lot of alternative universes too. Indeed, just before I started scripting this episode, I saw a new one suggesting we might have an anti-universe to our own that explained how we could exist. There, the majority of matter was antimatter, not regular matter, and time ran backward. And to them, this wouldn't seem backward. The idea that in pair production we have a regular particle moving forward in time, and its antiparticle moving back in time to self-annihilate with each other is one that's been proposed and discussed before too, even on this show. This sort of mirror universe isn't a new idea either, though the specific version and scientific reasoning for it was new. But anti-universes have popped up in science and science fiction before, and so have tales of dark mirror reflections of our world or their shadowy versions. Those are generally more metaphysical or even metaphorical takes on alternate universes, but we can't really rule those out either. It's a handy approach to the whole ex nihilo problem of getting something from nothing, that you get a positive something and a negative something and the two cancel out, so really you still had nothing, right? Philosophically, this is rather dubious as a solution. Those two things existed and thus came from somewhere under some rule or process, not nothing. They just add to zero themselves, but mathematically it works out. It's also a reminder that we live in a physical universe, not a mathematical one, and what works in math does not automatically work in the physical universe or the philosophical one. And indeed, physics is the field of natural philosophy and called that in some non-English languages. Nonetheless, this is our broadest notion of multiverses, an assumption that any place that can exist and be described mathematically does exist somewhere. We could argue this is the penultimate multiverse, since we could up that ante to say any place we can imagine to exist must exist, but both amount to all things which might exist do exist. The math part arguably matters since it potentially places limits on infinite things existing or paradoxical ones existing. We could push this a bit further by noting that our imaginations are limited and that all things including those we can't imagine exist, or simply that there is a lot we have yet to imagine which does, some beyond our mortal ken, or possibly knowable to very smart AI or posthumans. There are classifications folks have put together for multiverses. Max Tegmark has a 4-level system, of which the all-math version is level 4 and called the Ultimate Ensemble. The version Brian Greene uses has more types, and has the Ultimate Ensemble on there as Ultimate Multiverse. I've heard the term Ultiverse kicked around too, along with many others. My personal favorite was The Whole Shebang, which was the title of a book discussing such topics by Timothy Ferris that came out in 1997 when I was a 17-year-old college sophomore who had read a lot more science fiction books than physics. It wasn't my first introduction to the idea of multiverses of some type, but was the first time any of the science had really been explained. To my irritation, none of my undergraduate classes ever discussed it in more than glancing detail, and even graduate studies in physics barely brings it up. I remember complaining about that to my advisor, and him casually pointing at a book on the topic on his office shelves, and making a comment about how there's precious few research grants for the matter, so it wasn't exactly a priority in our curriculum. In retrospect, I agree with their more practical approach to focusing on useful skills or funded research. The whole shebang or the grand shebang was a fairly popular expression when I was a kid, so it appealed to me. I remember looking up what a shebang was years later, and that the best guess for the word's origin was that a shebang was a cabin or shack where unlicensed liquor was made or consumed. There's days when I think that probably is a very appropriate description for the sum total of reality. Though certainly less poetic than Carl Sagan's famous opening line,
"The cosmos is all that is, or ever was, or ever will be."
He goes on to give us all the justification we would ever need for exploring it.
Our contemplations of the cosmos stir us. There's a tingling in the spine, a catch in the voice, a faint sensation as if a distant memory of falling from a great height. We know we are approaching the grandest of mysteries.
But we are not limited to Sagan's sentiment for justification either. There's gold in them there proverbial hills if we can reach it, and a chance for salvation should our universe die. Another of my favorite wordsmiths, Ian M. Banks, the author of the Cultural series, has a type of hyperspace that involves moving under or over this universe. In that setting, our universe is one layer of an onion. Go down a layer and you get to a younger universe. Go up a layer and you are in an older one. Same rules in origin, but different parallel universe, and you can presumably go up many more layers or down many more too. This wasn't the only additional set of realities considered in the setting, but one from which we see an artifact assumed to be from such a universe emerge as it appeared to be older than the known universe, and folks contemplate fleeing to lower layers to escape heat death and entropy. This is in his novel Accession, which is perhaps one of the greatest sci-fi novels discussing superintelligent AI I've ever read, and done often from their perspective, which is very uncommon. Speaking of computers and minds, we get the expression computers all the way up, turtles all the way down, as a modern joke on the idea of our world resting on the back of a turtle, and when asked what the turtle was resting on itself, it being said it was on another turtle, presumably ad infinitum. The computers all the way up references the idea that we might be in someone's computer simulation, and then asks the inevitable question of if those simulators might be in one themselves. We played with that notion at length in our episode Hacking the Simulation, as well as ways in which someone in a simulation we made might be able to escape it, and thus how we might be able to escape our own if it's simulated. And of course we need no arcane motivation to explore such places either, or to create them when contemplating making such places. For our purposes today, any universe that lies below us in such an hierarchy is a subverse, whether it's a computer simulation we made, or some big bang we set off in a black hole, or via Clark Tech to forge some new pocket universe. The layer above would then be a superverse, and we'll go with that prefix as hyperverse or hyperspace tends to be used for other things. And saying Superverse keeps summoning to mind the Super Friends cartoon from the 70s and 80s I grew up seeing, and I can't narrate the episode if I keep laughing thinking of that every time I say it. Parent and child universes are also often used to discuss what we're dubbing superverses and subverses today, when it is assumed one descends from another. Alternatively, our onion layer example implies some greater reality each layer of that onion is blooming from. We might call this an epiverse, though I'm not sure it's a great fit as the epi prefix tends to imply an outermost layer rather than just a higher layer, and that seems like it should be reserved for when we're assuming that highest layer of reality if it existed, rather than just one more layer up. That top simulation or simulator or creator that was not made by a higher layer. The end of the road the others kick the can down. An epiverse strikes me as either some heaven-like place or something surreal and abstract beyond imagination, by definition some realm of utter chaos or madness, either of which might make for a place we'd really want to explore, but probably could not or should not, so we'll keep with Superverse and Subverse for today. But speaking of the lower and higher layers concept, as I mentioned some episodes back in our Fine-Tuned Universe episode, we do have very good reason to think there are other layers of reality and that we actively see and interact with some, but that the order is reversed. Those lower layers are foundational ones on which the higher layers are built. We live in a macroscopic realm built upon the emergent properties of the microscopic realm, which in turn is built on the very different rules and behaviors of the chemical and molecular one, upon the atomic one beneath it, the nuclear below that, the subatomic, and possibly more layers below, which is where string theory might come in. Higher layers are the planetary and galactic and then the end of greatness at the supercluster scale. These might seem mundane rather than the deeply mysterious alternate realities we often imagine, but they are very real and they are not the doll within a doll Matryoshka-like layers we often imagine, but very different layers of reality with very different rules. They simply seem mundane now because we found them, but they are very strange and distinct. We have no idea how far up or down that might go, though under the rules of quantum you do start getting hard limits at the Planck scale, but that's far down beneath the atomic scale. Indeed, the size of a Planck length compared to an atom is akin to an atom compared to the whole observable universe, so that leaves a lot of room for other scales still, and we can't take for granted you can't go lower still either. Many believe the realm of string theory lies below the subatomic, and we do not know how far beyond the scale of Hubble expansion and dark energy our universe stretches, either in space beyond the cosmological event horizon or before the Big Bang. It may go forever onward in space and time, or it might be finite in one or both. It may even be finite in one direction but not in others. In Tegmark's 4-layer multiverse, this would be one example of a level 1 infinite universe. This type suggests that our universe is just one region within an infinitely large space. Beyond our observable universe, there are other regions where conditions may be different. Though indeed you would expect regions that were exactly identical, since any finite volume, no matter how large and random, would repeat itself in an infinite universe. Generally, these regions follow the same physical laws and constants as our observable universe, but initial conditions, such as the distribution of matter, may vary. These could be explored with essentially any typical type of FTL drive common in science fiction, like warp drives. If we felt like speculating more in the realm of sci-fi than science, that the congruence of identical spots in the universe might allow instant transport to them, and then presumably the region of equivalence only needs to be so big beyond that. Given the far greater rarity of large or identical spots, it might allow a lot more places you could send a signal than a ship, and these smaller bits presumably don't last long either. Of course, transport might be automatic so that you were regularly slipping into identical other chunks of the universe without knowing it. Feel free to steal the notion for any sci-fi you might be writing, but emphasize that such identical spots, at least the Hubble volume scale, are arguably the exact same place. Same as over an infinite time, you will be resurrected over and over and over. Infinity is problematic, and also problematic to ever prove, since you would never know if you had simply reached a place where the universe looped back on itself or a random repeating spot, and wouldn't actually matter for any practical purpose I can think of either. Ironically, this vast infinity of time and space is actually a rather small infinity compared to the others we'll contemplate today. I already mentioned Tegmark's 4th level, the Ultimate Ensemble, and to fill in the blanks, level 2 is a bubble universe, and level 3 is the multiverse we see emerge from the mini-world's interpretation of quantum mechanics. This is very popular in science fiction in recent years, and is probably the one folks most associate with the term multiverse these days as a result, but we'll return to it in a moment. Level 2 bubble universes are based on the concept of eternal inflation of the universe. This is not the normal Hubble expansion variety we see in play with dark energy and distant galaxies redshifting, but references that early explosion in size we call the inflationary epoch. This theory posits that different regions of space stop inflating at different times, creating bubbles that are essentially separate universes, which may or may not be able to ever run into each other. For us, that inflationary epoch lasted from about 10 million to 100 billion Planck times. This is very short, as 10 million Planck times is about a trillionth of a trillionth of a trillionth of a second. During this very brief hypothetical epoch, the universe expanded much more rapidly than after, and for context, a bare instant later, though an eternity compared to the duration of this epoch, almost all of the hydrogen, helium, and lithium that exist in nature formed when the universe was now wide enough that its insides were similar to that of a supernova. Had that period lasted just a bit longer or been a bit more intense from the inflationary epoch being shorter or the expansion after being slower, then we would have had a lot less hydrogen and helium and a lot more heavier elements around. Had that dense early fusion period lasted just a bit longer, we would live in a universe in which there was only iron, nickel, black holes, and iron stars. The various bubble universes would presumably include lots of examples of these, along with many where inflation lasted too long and spread everything out too wide. But bubble universes can also include those that have different physical constants and laws, if we're assuming those initial inflationary conditions impact the strength of gravity, cosmological constant, speed of light, or other variables. We don't really know where those come from, but there's decent reason to think they might be set by those initial conditions. If so, this would also result in dramatically different environments, but ones we could explore if we could reach them, and presumably inhabit, as the basic constant of matter and energy should still function even if the default abundance of elements had changed or even the physical constants. Being able to go mine a bubble where things spread more slowly and thus were full of heavier elements and more packed together is obviously fairly handy, though given that you would have to travel beyond the edge of the universe to reach them may not be worth the travel time. Moving on to level 3, mini-worlds interpretation, this originates from quantum mechanics. This interpretation suggests that all possible outcomes of quantum events occur naturally, each in a separate, branching universe. As such, every possible state of every particle in our universe exists in a parallel universe, creating a vast, branching tree of universes. This one is arguably the least interesting for exploration for all the stories we have nowadays exploring it, because it's all mundane variations of what-ifs, and every what-if has a near infinite number of follow-ups, so there's no great new knowledge arising from answering what if Rome hadn't fallen, because the answer would be every conceivable scenario. However, it is the easiest for colonization and represents one of the few satisfying solutions of the Fermi paradox. There are a lot more atoms in Earth than planets in this universe, the observable portion of it anyway, and there is an identical Earth for each reality in which one of those atoms is just one tiny hair's breadth to the left of now, or to the right, or up, or 2 hair's breadths, or absent entirely. Thus there are so many more clones of Earth out there in such a multiverse than empty planets, and if you can travel to them, they are a lot closer than even Alpha Centauri, and no terraforming is needed. There's always a near infinite supply of them that are uninhabited by humans or any other intelligent critters, and to which we could simply step in and colonize. Now I said uninteresting, but that's obvious hyperbole. Every possible variation of Earth that could ever occur has occurred, including all those popular alternate histories for stories and their what-ifs of if Rome hadn't fell, or if Hitler had been assassinated or won, or if this or that war or plague never happened or was worse. Moreover, it's got an endless array where the dinos never died or got technology, or some other branch of humans arose, or where Earth had less or more mass or different continents or compositions. So yes, plenty to explore, but not with different physical constants or rules. This still gives you access to a vast amount of resources and lands to settle though, dwarfing anything our observable universe would offer, and presumably more easily reached. That said, if you can reach it, you actually would have to have additional variations for universes or worlds where Earth had X amount of matter, but now you had suddenly appeared on it, introducing exponentially more variants, and many more for ones where a minor variant of you with just one atom out of place also existed. Such places are arguably impossible to conquer all of, because there's always more where your conquest never occurred, or failed, or you got bored and stopped, or Kang beat you to the punch, since it must encompass all possible solutions. This is also where your perfect repetition issue might come up, since if we imagine two near-identical Earths sending identical copies of you to some empty multiverse planet, we would have no way of telling if those two each went to a different but perfectly identical place, or simply merged, one copy of you where two of you were sent to the exact same place and time. For more discussion of multiverse conquest, see our episode Multiverse Warfare and Quantumania. And again, Take Marks isn't the only scheme for discussing this, and we have other options that deserve some mention. The Brane multiverse, stemming from string theory and M theory, posits that our universe is one of many three-dimensional branes floating in a higher dimensional space. This is brain-like from membrane, not the thing on your shoulders, trying to figure out all these crazy concepts. These branes can collide and interact, potentially explaining phenomena like the Big Bang. Each brane can host a universe with different physical properties. Arising as it does from string theory, this is probably the second most commonly discussed multiverse in science fiction. It obviously includes a lot of options for strange new worlds to visit, but it's perhaps more interesting for the implication you could set off new Big Bangs with some tweaking and maybe to the characteristics you desired. Another common one for discussion, even pre-science, is the Cyclic multiverse. This was very popular when we thought the Big Crunch would follow along eventually, as gravity took back over and pulled the universe back on itself, and folks thought that maybe it would then bang again and we keep seeing a repeat. This could be an identical universe over and over, but often is assumed it would play out a little different, and if we keep having the same amount of mass or energy constantly exploding, crunching, and exploding again, this is identical to the mini-worlds multiverse, as all possible examples of the universe will eventually unfold. Travel between them would require finding some way to avoid being crunched, and might mess things up by adding or removing matter or energy from the cycle, though you might simply transfer information instead. Thinking of the bubble universe options, we could also add in more variations where the inflationary epoch was longer or shorter, or different values for physical constants emerged with each new crunch and bang. Exploring these multiverses definitely requires going the long way around, as the 12th Doctor Who might say, as you would have to last through each new incarnation of the universe, and only if you had a time travel device can this really be said to be exploring rather than experiencing, as there's no going back. Unless you wait long enough, of course, for lengths of time measured with the sort of mind-boggling huge numbers that just jotting them down on a piece of paper would require so much paper it would collapse into a black hole. We'll be getting to the concept of the Library of Babel next week, for those watching this on Nebula anyway. For everyone else, we got to it last year, and that's the notion of a library in which every possible book that could be written is kept, and it's basically insanely huge and could not exist in normal reality, again collapsing into black holes. And for those who remember telephone books, the nominal phone numbers or gate addresses for each multiverse would not only be a very large number of digits per address, but so many of those addresses as to be impossible to record. Incidentally, the Cyclic universe is not entirely dead, with the Big Crunch being out of favor. The eternal expansion heat death might permit it too, under Roger Penrose's conformal cyclic cosmology, where we see a conceptual repeat of the idea that if you can't observe or measure things or differences, they can suddenly cease to exist or arguably not matter. See our episode on that and ghost universes for more discussion. Another one arising from string theory and offering us many strange landscapes to explore is the landscape multiverse. In string theory, there is a concept for a landscape of possible vacuum states. This has to do with the idea of vacuum energy and false vacuums. See our vacuum energy episode for more discussion. But this theory suggests that each vacuum state corresponds to a different universe with its own physical laws. For conceptual purposes, think of our apparent false vacuum of normal empty space in this universe as the top of the ocean on which we float, and the real or true vacuum being the ocean floor under all that water. Other universes then have their true bottom at a different depth than ours. The vast number of possible vacuum states in string theory implies a huge number of potential universes, and we could imagine traveling to these by puncturing a hole in the bottom of reality to slip to the next landscape below, so to speak. Just as string theory offers us a few different multiverse options, quantum offers us more than just the mini-worlds version. A quantum multiverse is an option similar to mini-worlds interpretation, but rooted more in the framework of quantum field theory, suggesting multiple coexisting universes arising from quantum processes. There's multiple versions, appropriately, but generally this hinges on different configurations of quantum fields being able to lead to the existence of different universes. We also have the holographic multiverse, which does not, as the name implies, indicate a fake or ethereal one, except arguably ours. The holographic principle suggests the entire universe can be seen as a two-dimensional information structure painted on the cosmological horizon. Unlike a lot of speculations where we imagine additional dimensions which did not expand when our basic three physical ones did, this version suggests less than three dimensions, that our 3D universe is an illusion, and the true nature of reality exists in a lower dimensional space. Multiple such 2D surfaces could represent different 3D universes. And of course, mentioning the idea of extra dimensions that didn't expand, we must consider ones in which additional dimensions do exist, and some of them did expand, maybe just a little, maybe infinitely, maybe somewhere in between. Exploring these would be rather tricky since you must now find a way to create stable, four-dimensional matter to build sensors, receivers, drones, androids, or even people out of. Or five-dimensional ones, or higher, maybe even as much as 26. We discussed problems with this more in both our Fine-Tuned Universe episode and Higher Dimensional Aliens episode. But speaking of fake universes, while the holographic universe doesn't imply that, simulated universes or multiverses do, though the term fake gets a bit questionable. These would be examples of a subverse from a higher superverse, which is where the computer was at that made them, though this can also include the dreams of gods or mad fevered imaginings of Boltzmann brains. These would probably be the kind of multiverse most easy for us to explore, since we can presumably make them with very good computers, and we have explored them more in our episodes on virtual worlds or simulation hypothesis. It should be noted that if we're imagining ourselves as a simulated subverse, then we have 2 points worth considering. First, that if we're meant to be a variation of their universe, these are generally called ancestor simulations, as they tend to assume alternate history simulations and the like. It's their world, but maybe with some difference. Alternatively, that simulator might be higher dimensional and operate under different physics, much as some old Nintendo video game with a scrolling 2D background, or one where you might walk off one side and re-emerge on the other, which is not like our own 3D universe and its rules. Before we wrap up today, I just want to take a moment to thank everyone who's joined the channel over the last year since we introduced YouTube memberships. The extra support there, or from Patreon or PayPal, helps us keep making episodes, and if you're looking to help out, click the join button or check out other methods in the episode description or at isaacarthur.net. Going back to higher dimensions, channel regulars know I tend not to be a huge fan of string theory. Not because it's a bad theory, but because it doesn't have really any way to prove it or evidence for it. This isn't necessarily true though. Parallel universes in higher dimensions is another of our multiverse options and builds on theories of higher dimensions, such as those in string theory beyond the 10 or 11 dimensions usually discussed. Here, universes exist in dimensions beyond our own, and interactions between these dimensions could occasionally affect our universe, potentially observable through phenomena like gravity or cosmic rays. This isn't the only multiverse option that might be in some way provable, and thus also potentially be able to be interacted with too. Penrose's conformal cyclic cosmology has those ghost universes I mentioned, or incarnations of the universe that leave a gravitational telltale on the next incarnation. Others might very literally be something you can just step to or that already exist with one foot inside, as I was mentioning earlier with the idea of viewing our macroscopic, microscopic, atomic, and subatomic layers of scale as effectively foundational layers of reality the other higher layers were emergent properties of. And there are more we don't have time to explore today, but let's give 2 last honorable mentions. We have quantum computational multiverse that suggests each universe is a different state in a vast quantum computation, merging quantum mechanics with computational theory, proposing that the multiverse is essentially a giant quantum computer running all possible computations. Lastly, there is the consciousness-centric multiverse, another idea originating from Roger Penrose. This theory incorporates the role of consciousness in the creation and perception of universes, observations, observers, and the notion of consciousness possibly being necessary for observing. And this is a hot topic in quantum mechanics for discussion, and sometimes heated discussions at that. Here we see it suggested that consciousness is a fundamental component of reality, influencing the formation and experience of multiple universes. It's arguably a multiverse killer because it's taking the other view on quantum, that many worlds are possible from each quantum event, but that once observed, one is preserved, and the others all disappear in a puff of unreality. I'm sure I've mentioned before that I tend to tilt toward the Copenhagen interpretation over many worlds or the many other versions, and this would be a variation of that. Copenhagen is the Schrodinger's cat version where the cat is simultaneously alive and dead in a box, and when you open the box to check, it becomes one or the other, rather than having two universes, one where you opened it and found an alive cat, another the dead cat verse. Discussion of the observer, observers of observers, and who counts as an observer is a whole different episode, but there's a debate about if consciousness is really required to be an observer of it, or if alternatively consciousness arises out of quantum effects, and this is not really compatible with many worlds multiverses, the Take Mark Level 3 variety. It is, however, completely compatible with cosmological multiverses like ours just stretching out forever, or being one of many local bubbles, or many of the others too. So don't worry, if you prefer Copenhagen over many worlds, you still have no shortage of multiverse options you might be able to explore. In the end, we don't really know if any of these is true, let alone which we might be able to ever detect or visit. All of them offer options for a near unlimited humanity, and not just more room to grow, but more ways of circumventing entropy, powering or cooling or otherwise fueling endless empires of unimaginable scope. Time will tell if there's any gateway to such realms, but the good news in the short term is our own more mundane universe is already a place of such immense scope that it would take countless trillions of people billions of years to explore, so we're not likely to get bored anytime soon, even if multiverses aren't available to us.